Yes friends, so we are doing question number 9. Now in this we have to just find out probability of heads turn up exactly 3 times. Or 3 times heads are turning up when coin is tossed 5 times, as I have told you. Total number of cases are 2 raised power 5. 2 raised power 5 means 32. Total cases are 32 in this case. So total number of cases. But exactly 3 times. That means out of 5 heads we have to select 3 heads. So 5C3. This is selection formula, combination formula we have to use in the numerator. But in the denominator we are having 2 raised power 5. Why? Because 5 times coin is tossed. 5 times. So 2 raised power 5. 2 into 2 into 2, 5 times. 2 into 2, 4 times is 16. 2 into 5 times means 32. So 16 to 32. Total number of cases are, in this case, let me write here, total cases of coins tossing 5 times. Total cases of coins tossing 5 times is equal to 2 raised to 5, because 1 time it is 2, 2 times it is 2 raised power 2, 3 times it is 2 raised power 3, 4 times 2 raised power 4, and 5 times it is 2 raised power 5. In this way we calculate. So this is 2 raised power 5. That means 32. 2 raised power 5 means 2 into 2 into and so on. So this 2 raised power 5 is the total number of cases. Total number of possibilities are 32. Alright, if a coin is tossed 5 times. Then what is the favorable cases here? And the favorable cases is equal to 5C3. What does it mean? 5C3 means out of 5 heads we have to select 3 heads. Selection. Only 3 heads exactly we have to select. This will give us factorial 5 into 4 into 3. Whatever the number in place of n is, NCR is in place of n, whatever is there, numerator. In the denominator, sorry, in place of r we are having 3. So 3 times we have to write backward 5, in descending order 5, 4, 3, 3 times. And 3 is to be written 1, 2, 3. So factorial 3 in the denominator. This is the final answer, 1, 2, 3. In this way this 5C3 is opened. You can do in that way also, that factorial 5 divided by factorial 3 into difference of that means factorial 2. Because difference is 5 minus 3, factorial 2. What is NCR? We know that NCR formula, combination formula, is factorial n divided by factorial r into factorial n minus r. This is the basic formula. But we have to just solve it. Factorial 5 upon factorial 3 into factorial 2. What the final answer? Factorial 3, suppose I have put as it is. And factorial 5 is opened, 5 into 4 into 3 into factorial 2. Now factorial 2 is cancelled out in the denominator. 1, 2, 3, which was value of r factorial, is just expressed in the denominator. So in this way we can solve it. So 3 cancel out, 2 2 are 4, so 5 will 10. Only 10 in the numerator. The number of favorable cases are 10. Favorable cases 5C3 equal to 10. 10 is the favorable cases, total number of cases are 32. So finally, probability of, therefore probability of exactly 3 heads. Is equal to, let me write formula 5C3 upon 2 raised power 5. This is the basic value which we have to solve. Here. So 5C3, we have to select out of 5 heads, 3 heads. And total cases are 2 raised power 5. This is 10, we have just calculated. 5C3 is 10 upon 32. This is, so 2 5 and 2 16 times. It is nothing but 5 by 16. This is the answer. The probability is 5 by 16. Now this is prime to each other. 5 cannot cancel out 16. 5 and 16 both are prime to each other. So this is the final answer. So answer must be in co-prime numbers, prime to each other, right? Is the answer here. So this is how question is to be solved. Now question number 10, let me talk about it. What is question number 10 say? Let me first check it, that what is question number 10. Question number 10 says, let me check it. Okay, so this we did. Now question 10 is when 6 coins are tossed at a time, or we can say one coin is tossed 6 times, same thing. Now it says when a coin is tossed 6 times, so when 6 coins are tossed at a time, find the probability that at least 5 coins turn up heads. So 5 heads are turned up, or 5 coins turn up a head. At least. It says at least. Try to understand. Minimum 5. It means 6 heads can also be there. So what are the two possibilities? 5 heads and 6 heads. Because at least 5. Maximum, more than 5 also possible. As I told you that at least means minimum. Minimum 5 plus 6 heads will also be there. The two cases we will take. Favorable cases will be 5 because it's 6 times it is tossed. 6c5, 5 heads plus 6c6 because 6 heads can also be there. 5 heads plus 6 heads. Okay. What is given to us? 6 coins are tossed. Let me take 6 coins are tossed, or one coin is tossed 6 times. They say when a coin is tossed, sorry, 10th question. Okay, it says when 6 coins are tossed at a time. So 6 coins are tossed at a time. At a time. Now to find here, what we have to find out? To find here, then okay, to find the probability. Find the probability that at least 5 heads are. Find the probability. Find the probability that at least 5 heads are turned up, or 5 coins shows heads up. At least 5 coins turn up heads. At least 5 coins, it says, let me take the same way. 5 coins. At least 5 coins turn up heads. 5 coins turn up heads. This is very important point here. So that's probability we have to find out. Now try to understand what are the possibilities. As I told you, at least means minimum. At least 5 here means, at least 5 means minimum 5. This implies that 5 plus 6, 5 heads plus 6 heads. These two cases are there. So these two cases we will take at minimum 5, but 6 can also be there. Whatever the times or 6 coins are tossed, so 6 times head can also appear. That event can also be, will also be included here, minimum 5. At most means maximum, top level is put, not beyond that. Lesser than that but possible in case of at most, but in at least minimum level is put, and up also we will take. 6 heads are also taken. So total, so favorable cases are, hence favorable cases, and favorable cases are, because 6 times it is turned, out of 6 heads we have to select 5 heads plus 6 heads out of 6 heads. These two possibilities are favorable. What are these two values? 6, this is value 6, it says 6c6 is 1, with factorial 6 upon factorial 6, right, into factorial 1, or sorry, 0 also, factorial 0 is 1, 6 factorial upon 6 factorial is 1, the 6c6 3 is this, and 5, 6c5 is 6 only, because 6 into factorial 5 upon factorial 5 into factorial 1 is 1. This is 6 plus 1. So total favorable cases are 7 only. And what is the total number of cases? 2 raised power 6. Because the coin, so total is, so at least this is favorable cases are 7. Okay. Now total number of cases and total number, let me write here, and total number of cases, total number of cases, 2 raised power 6, because head is or coin is tossed 6 times, so 6 coins are tossed together. That means 2 raised power 6 total possibilities will be there. That means 2 raised power 6 is 64. 2 into 2 into 2 6 times, that means 64. So 7 upon 64 is the final answer. Hence probability of at least 5 heads, at least 5 heads is equal to 7 upon 64. Try to understand. Total favorable cases are 7, favorable cases upon total cases are 64, 2 raised power 6, 64. 2 into 2 into 2 6 times. Okay, so 8 into 8, that means 2 3 times means 8, 2 3 times 8, 8 into 8 64. 64. So this 7.6 is the answer. Okay. Question number 10 completed. Let's talk about question number 11 and then question number 12. Question number 11, what is it? What is given to us here? Question number 11. What is given to us here? 11th question says when 8 coins are tossed at a time, find the probability that, first part, what is the chance that then find at most 3 coins turn of tails, turns of tails. 3 coins turn of tails here. Okay, so let's find out this. That is given there. At most means maximum. 3 coins turn of tails. So a coin is tossed 8 times. It says when 8 coins. Okay, 8 coins. It says 8 coins are tossed at a time. 8 coins are tossed at a time. That is the point here. It says, right, when 8 coins are tossed at a time, to find here probability, to find the probability of at most 3 coins turn of tails. At most 3 coins turn of tails. Try to understand here, tails. So 8 tails may be there because 8 coins are tossed, or 1 coin is tossed 8 times. So what is the total number of cases here? Look, at most it says. At most means maximum 3. It may be 2 also, it may be 1 also, it may be 0 also. So in this case, solution, let me find out. Okay, so favorable cases are here, since, or here, favorable cases will be 0 tails, try to understand 0 tails, 1 tail plus 1 tail, that is also 1 tail, 2 tails, plus 3 tails, because at most 3 tails. That means how many cases are there? Out of 8 tails, out of 8 we have to select 0, 8C0, plus 8C1, plus 8C2, plus 8C3. Here are the 4 cases here. Total favorable cases are these. We have to find out the value of these. What is this? Factorial 8 upon factorial 0 into factorial 8. Why? Because 8 minus 0, difference is 8, so is 1. This is 1 here. 8C1 is 8 only. Why? But difference is 7. So 8 into factorial 7 upon factorial 7, 7 is the cancel of 8 only. So what is 8C2? 82 is 8 into 7 upon 1 into 2 plus this is 8 into 7 into 6 upon 1 into 2 into 3. This is direct formula. Whatever the factorial of 3 we have to put here, or 8, the n is to be expressed only r times whatever r value is given. This is 3. So 8, 7, 6, 3 times, because r value is 3. R is 2 here, so 8 into 7 upon 1 into 2. It is only 1 time 8. Right? That is the answer. So let me solve it. 3 to the 6 cancel out. And this 2, 4, the final value is 1 plus 8, 7 4 the 28, 8 7 the 56. Total this will be 6 plus 8, 14 plus 8, 22 plus 1, 23, 3, 23, 3, 2 carry, 2 plus 5, 7, 7 plus 2, 9, only 93. Let me again check it. 6 plus 8, 14 plus 8, 22 plus 1, 23, 3, 2 carry, 2 plus 5, 7, 7 plus 2, 9, all that, 93. 93 cases are the favourable cases. Favourable cases are 93. Therefore, probability of this will be, let me find out. Hence, probability of at most 3 tails. At most 3 tails is equal to, let me write here. Total cases 8C0 be calculated 8C1 plus 8C2 plus 8C3 at most upon 2 raised power 8. Why 2 raised power 8? The total number of cases are 2 raised power 8, because in 1 time 2, 2 times 2 into 2 raised power 2. So this is 93 upon this total value we have just calculated, 93 upon 2 raised power 8, means this is 64 6 times and into 4 also, because 2 to the 4, 6 times it is 64. Okay, and 4 more, 4 or 4 2 more, 2 more, 2 into 2 more, that is 4 or 4 more. So this is 93 upon 4 4 is 16, 6 1 carry, 4 6 is 24, 1 25, 256. 93 upon 256, this is the answer. 256 in the denominator, 93 in the numerator. This is the final answer. Try to understand this question. Simple. So number of favourable cases divide total number of cases. Total number of cases are 2 raised power 8, because of 8 points are tossed together. Let us take question number 12 here. 11th we have done. Yeah. Now 12th question is, what is given to us? Try to understand. There are 2 parts here. What is given here? We have to find out a leap year and not a leap year. Okay, so number of, let me write here. Now we are given here number of days in a leap year. Let me find out. In a leap year, we know that what is the leap year? In which February is of 29 days. So 1 day more is added up. That means 365 plus 1, 366. So number of days in a leap year is equal to 366. Now if I divide it by 7, so 2 will be the remainder. How? 7 5 is 35, 7 5 is 35, 1 carry 16, 7 2 is 52 weeks will be there, and plus 2, because 7 to the 14 and 16 it was, 16 minus 14 2, so 2 is the remainder, 2 upon 7. This is the value here. We can write it like this, 52 and 2 upon 7. So this much number of weeks are there. This is number of weeks are 52 plus 2 days more. So 2 days more are left. So those 2 days may be what? Now we have to find out the number of days in a year. Leap year, we know that. Without leap year it is 365 days. That means 1 will be the remainder. 1 more day will be there. If you find here a leap year or not leap year, now what is the chance that a leap year selected randomly will have 50 to 53 Sundays? That is 52 Sundays are here and 53 means one more Sunday. So what's the probability? We have to find the probability of 53 Sundays in a leap year. Second part of this is, the second part it says